Imagine something that's never been done before in order to push the boundary of where you want to go. How do we train the models of the future about the biology we know today, especially in immunology? The thing that I learned about career and about success is that you actually have to embrace the randomness, the stochasticity of life.
Hi everyone, welcome back to OncoDaily. It's a great honor and pleasure for me today to welcome Alicia Zhou from the Cancer Research Institute. Thank you, Alicia, for taking this call and for agreeing the interview. I'm not going to go into your bio because we are going to explore it during our call. Thank you very much.
Thank you so much for having me.
It's a great pleasure. MIT, Harvard, then University of California, San Francisco. I mean, you did a lot of stuff during your education. Please, can you explore what did you do? I mean, in the beginning of your scientific career, and then we'll see how you came here.
Sure, absolutely. I am someone who fell in love with biology at a very early age, and I just knew when I was in high school that I really was interested in the life sciences. And I had the privilege actually to go to an amazing high school that was associated with the University of Chicago, and it was called the University of Chicago Lab Schools was the name of my high school. So I actually got to work in a wet lab when I was a high school student. So I actually started working in the lab of Dr. Jeff Green at the University of Chicago. He is a breast cancer researcher working on the estrogen receptor. And I was probably 15 or 16 when I started working in his lab, and he gave me an amazing opportunity to get my hands on true biology. And so I joined his lab as a technician, and I was able to start working on subcloning and doing some of the sort of standard protocols for the lab. I learned all sorts of bench science, which I think really opened my eyes to what science could really be. And also, he's the person who really started me down the path of doing cancer research. So when I went to MIT for undergrad, I knew that I wanted to work in cancer research. And so I actually just very naively Googled MIT cancer researchers. And the first name that popped up was Bob Weinberg. And I actually didn't really know who he was, which is ironic and tells you how little I knew about the field at the time. But MIT had this amazing program called the Undergraduate Research Opportunities Program, UROP. And so I reached out to Bob and asked if he'd be willing to have me in his lab as a UROP, as an undergraduate researcher. And I don't know if you've ever met Bob Weinberg, but he's one of the kindest people in the world. And I
have a funny story with him, but we will cover
everyone has a funny Bob story. So he agreed to meet with me, and I walked across campus, and I was a freshman, and I walked into his office. And during the course of being with Bob, I realized how amazing it was, how lucky I was that I got to work with one of the sort of truly founders of oncogenes and cancer research, literally the person who wrote the book on cancer biology. I actually helped work on his textbook when I was in his lab. I worked in Bob's lab for basically 4 years while I was an undergraduate. And still to this day, my most cited paper is a paper that I was a middle author on because of being in Bob's lab. I subsequently did my PhD at Harvard, and staying in the Weinberg family tree, I did my training with Bill Hahn, who is also a Bob Weinberg alum. And in Bill's lab, I had the privilege of being at both the Dana-Farber Cancer Institute and the Broad Institute. And, I actually got to see them break ground on the Broad building. And during my PhD, I had the amazing opportunity to be on the 15th floor of Dana-Farber with Bill Hahn as my PI, but then Matthew Meyerson, Levi Garraway, Todd Golub. So it was really sort of the heyday of oncogenes research. And so I got to really see how data-driven research transformed the way we did all of our work. It was the days of TCGA. It was the days of understanding how to pull up the genomics platforms. And so then from there, I came to California to do my postdoc at UCSF. I trained with Andre Goga, who's a MYC researcher. And I had the privilege also at that time to work with Mike Bishop, who, of course, discovered MYC. As you can tell, I was really wanting to be just a cancer researcher, and that was really my path. And so that was sort of all of my education background, and that's really what drove me to continue down that path.
And then how did you become the CEO of the Cancer Research Institute?
Yeah, it's a great question. So
Don't
when
skip
I
the
was
steps.
I know. So when I was a postdoc, I actually being here in the San Francisco Bay Area, there's just a wealth of opportunity to join companies. And I had never considered leaving academic science. Actually, for me, academic science was always the path. But there's something in the water here that makes you want to try entrepreneurship. And so I actually, in 2015, left academic science to join what was a small startup company called Color Genomics. It was a 30-person Series A company that was really trying to take BRCA1 and 2 germline genetic testing and make it more affordable and accessible to every patient. And I thought this was so interesting, taking a lens of having worked on cancer research from the academic bench. Now this is about taking a product and making it easy to use and affordable in cancer care for patients. And so I took a leap of faith and I joined that startup and in 2015, and then actually had the privilege to be part of that company for 9.5 years. And so I was actually there for a lot of growth. We went through multiple rounds of fundraising. I became their chief science officer, and I became leading their scientific affairs team, their medical affairs team. I learned a lot about how to build clinical diagnostics, how to interface with the FDA, how to think about regulatory compliance in these different ways, how to sell to customers, how to plug into the ecosystem of healthcare. So it was an incredible experience for me. And then about a year ago in 2024, I was recruited to come and lead the Cancer Research Institute, which of course is a nonprofit organization that funds cancer research. And so it's a little full circle for me to come back to cancer research and academic science in this way. And the way that I describe it to people is I have sort of three unique vantage points on science or on cancer. I've had the opportunity to work on gain of function in oncogenes. I've had the opportunity to work on loss of function in germline genetics. And now here at CRI, we focus on tumor microenvironment and tumor immunology. And then similarly, I have three very distinct sort of business vantage points. I've been an academic scientist, I've been an industry startup executive, and now I'm a nonprofit executive. And so I have a really strong point of view actually about what the unique value each of these organizations and each of these parts of cancer research can add to sort of really solving this problem. Because I do think we are on the cusp of some pretty big discoveries and changes in this field, and it's really a privilege to be able to sit and work on this from this vantage point.
Alicia, while I was reading the announcement about your appointment, I came across to the words from James Allison. I mean, how highly he was talking about your appointment. How is it to have this kind of quotes about yourself from a Nobel Prize winner?
I mean, it's a little surreal. Jim is an incredible scientist, and he is somebody, of course, who's a giant in the field. And I think what's really amazing about Jim is he maintains this. He has changed not at all since winning the Nobel Prize. He's always been this very biology-driven, curious, humble scientist who has always wanted to really understand the biology of the immune system and how it interacts with cancer. And since winning the Nobel Prize, it hasn't changed him at all. I think if anything, it's given him a platform. But I think it's always amazing for folks to interact with Jim. And yeah, it was surreal to have him say those things about me. And of course, it's amazing to have his partnership. He's the director of our Scientific Advisory Council, which means that he leads the scientific reviews for our scientific programs. So we make a lot of grants, and the Scientific Advisory Council are doing peer review of those grant applications, very similar to how the NIH does it.
Alicia, who are your mentors? You mentioned a lot, but if you name...
Yeah. Oh, I have so many. Yeah. I mean, obviously, I would say Bob Weinberg has had an incredible impact on me. I think that I was such a young trainee when I was with him in his lab. I was between the ages of 18 and 22 while I was with him. And he was such an incredible mentor, because I think what he showcased to me was that even at his level of science, even though he is credited with sort of discovering the entire field of oncogenes, and he's so revered by everybody in the field, the curiosity never stopped for him. And the way that he would show up at every lab meeting asking good questions, the way that he would come through the lab and sort of be looking at everybody's projects with that lens of pure scientific curiosity, I thought that was incredible. It made me realize that this is a person who really embodies the spirit of discovery. And I think he inspired a lot of that in me. I think also just seeing how he really still was investing in mentorship and training, even though he didn't need to. You know, at that point in his career, he could have delegated that to everybody else. But he knew who I was, and he knew what I was working on. I would have one-on-one meetings with him, even though I was an undergraduate researcher. And so that really meant a lot to me. And I think it also showed me the power of really good mentorship. And I think I look back on that all the time and think about how I can pay that forward, because he didn't need to take that time with me, but he did. And that really inspired me to sort of think always about training and mentorship.
What is key to your success?
That's a good question. I think this is really interesting because I think as scientists, we always think of ourselves as being very organized, and we always have a plan. You never start an experiment without thinking through all of the conditions. You have your control arm, you have your experimental arm, you order all your reagents ahead of time, you write it down in your notebook, and you execute against the protocol. And so we're trained to be these very sort of logical thinkers and linear executors. You know, we have steps 1 through 10, and we do them in the exact order. And that's what makes us good scientists. I think the thing that I learned about career and about success is that you actually have to embrace the randomness, the stochasticity of life. So for me, it's actually about making myself open to opportunities as they come, and then sort of trusting my gut about where I think I can make the biggest impact. So when I think about sort of what's the North Star for me, what's helped me get to where I am today in my career, it really comes down to having a strong point of view about mission. So I always knew that I wanted to work on something that was related to biology, that was in the field of cancer biology, and that then this last piece is really the key, which is that I wanted to maximize my individual impact on the good I could have in the world. And that means that on any given day, when I'm thinking about what decisions I can make, that's sort of a North Star driving function of saying, okay, well, in this position, here's how I can maximize my impact versus that position. And then it's not about chasing then a specific goal or a specific title or a specific role. It actually becomes sort of this very natural, almost organic growth that happens when you kind of just always are asking yourself, is this how I'm maximizing my impact? And that's always been really key for me. And so when I talk to scientists, I always say you have to let go a little bit of that control that we're so used to at the bench, and actually have to embrace a little bit of that randomness in order to be successful.
If you were to advise, I mean, what kind of advice you have for much younger generation, like who think that one day they will be a CEO of like a national big research institute?
Yeah, it's a good question. So I would say there are a couple of things that are really important. Obviously, starting with a foundation of science is incredibly important. So making sure that you have a strong training background, knowing that you actually do have a real passion for the field is important. I think from there, then there are a couple of key traits that are important to sort of build and skills to have. One, I think that is incredibly important is scientific communication. I think oftentimes as scientists, we think about just putting our head down and doing the work. But the reality is that in order to be able to maximize your impact, we actually have to be able to talk about the work in a way that's compelling to audiences that are both scientists and non-scientists. And I think sometimes scientists kind of defer that communication to somebody else's job and say, oh, somebody else will help me tell that story. In reality, it's an incredibly important skill for every scientist to have. And so I don't think of it as an optional thing, a skill to build. I think of it as a necessary skill for all scientists. I was really privileged when I was training that I actually took classes in scientific communication. At the time, I didn't know what it was, but it was literally about how do you make a PowerPoint slide to talk about your data? How do you set up a presentation that goes through your experiment and your methods and then sets up your conclusions? And there's a real sort of method to that, and learning that and understanding, how to tell a compelling story is incredibly important. I think the other piece of it is that in order to become successful and become a leader, there are all sorts of other skills outside of the technical skill set that you really do need. We call it EQ or people skills, but it's actually your ability to understand in any given scenario or conversation, what is every party in that conversation optimizing for? What are you optimizing for? And then how do you drive towards an outcome that you're looking for? That takes practice. So for me, actually, I always tell people, so outside of science, when I was in college, I competed in a Korean national martial art called Taekwondo. And I spent a lot of my time doing Taekwondo at MIT. And I actually had the privilege to become a member of the collegiate national team in 2009, 2010. So I traveled around the world and represented the United States at World Championships for Taekwondo. Everything that I know about influence, everything that I know about how to drive people towards an outcome, I actually learned from Taekwondo and not so much from being in the classroom. And it's really about how do you sort of show your knowledge and expertise and influence a group of individuals. And it comes from all of these skills that are not about being the smartest person in the room, but actually being the most perceptive and then being able to drive folks towards a shared outcome.
What are the books which shaped you?
I'm a mom of a 10-year-old, and my son, Davi, he really enjoys reading. And one of the things that I always think is really important in kids, and I was this way, is just to encourage that voracious curiosity and imagination. I think that we spend a lot of our times, especially these days with kids, they spend a lot of their time online and they're not even reading books anymore. But for me, I feel like I spent a lot of time reading science fiction and fantasy novels when I was growing up. And it really has just completely exploded the universe of possibility. And I think sometimes we underestimate the importance of imagination in science, but actually you have to be able to imagine something that's never been done before in order to push the boundary of where you want to go. So I would say growing up, very influential on me was the entire Star Wars universe. I watched all the movies and then I read all of the books. And then, of course, as I have become an adult, I maintain this balance of wanting to read really interesting fiction, but then also I actually love reading the primary literature. I know that sounds really crazy. But I actually enjoy sitting down and reading a lot of the journals and really thinking where the science is going. I think from a leadership perspective, one book that I really enjoy is called Working Backwards, and it's really about the Amazon sort of perspective on how to get to a shared goal. And I think Working Backwards really breaks down how you think about leading a group of high-functioning executives towards delivering products. So that's a really great book when it comes to thinking about leadership.
About your work at Cancer Research Institute, what you do there?
Yeah.
What's special about it?
Yeah. So the Cancer Research Institute, CRI, we're a nonprofit organization. We're actually originally founded in 1953 with really this goal of helping to fund the basic research that's going to help us discover new treatments for cancer where we can activate the immune system to treat cancer. And of course, in 1953, that entire field didn't yet exist. And so in many ways, CRI is the original foundational funder of immunotherapy, sort of this concept that we have today of being able to treat the immune system or activate the immune system in order to treat cancer. Today, we make about $40 million of grants a year towards basic science and translational science research. So we make grants towards postdoctoral fellowships, towards mid-career faculty and early career faculty. We also fund clinical trials and translational research. We are starting a new initiative on how we think about embracing data-driven discovery and AI-driven discovery, and what are the right data sets that are necessary necessary to power that. And then, of course, what's really interesting about CRI is we were founded before immunotherapy existed in many ways. We're the catalyst that caused immunotherapy as a field to flourish. And now it's been 15 years since the approval of the first set of immunotherapies. And we have all of these patients now who are being treated. And so a new program pillar for us is our patient pillar, making sure that we are delivering good educational content and useful resources to the patient community. And so CRI is really a nonprofit organization very focused on how do we accelerate discovery for immunotherapy, investing in basic and translational research.
What is next?
Oh, great question. So, I mean, this is somewhat obvious, but the way that AI is accelerating every single thing in our lives, it's going to change the way we interact with literally everything we do in our lives, from the way that we think about acquiring knowledge to the way that we communicate. I'm sure it's going to change the way that we bank and the way that we drive and all of these things. And the question is, how is it going to change drug discovery? And from my point of view is it's absolutely going to have an impact on drug discovery. So how do we think about that for cancer biology and drug discovery and immunotherapy specifically? What we know about these models, these large language models that have powered generative AI and also some of these transformative algorithms like AlphaFold, is that they work incredibly well when they have a source of truth data set that they can go back to, sort of a golden standard or a foundational data set. And so I think a lot about how do we train the models of the future about the biology we know today, especially in immunology, where we know this is an incredibly complex system with multiple different cell types that interact with each other over time in very nuanced ways. So we know that the next chapter for cancer drug discovery is very much AI driven. And so then how do we invest in the resources that will help accelerate that part of the curve? So I'm thinking a lot about what are the foundational data sets that are necessary that will help to train up these models. I think the compute is already there, right? We know the compute is there because it's already transforming the way we communicate. The question is, how do we now use those same algorithms, use those same methodologies to predict how biology works? And there, I think that's the next chapter.
Wonderful. Thank you very much, Alicia. If you describe yourself in one sentence, who is Alicia Zhou?
That's super hard to do in one sentence. I think the best way to describe myself is that I am a mission-driven biology nerd who is trying to maximize my individual impact on the world.
Wonderful. And before I come to my last question, is there anything you would like to share?
I think the only thing that's worth making sure people understand is that, this is a really interesting moment for biology and biomedical research, especially in the United States. We're seeing this sort of contraction in federal funding for biomedical research at the same time that we're seeing this explosion of potential discovery because of AI-driven discovery. This is not the time to pull back on investment in biology. This is the time to really add fuel into the tank. And so for us at CRI, I'm always asking myself, what can we be doing that's going to help bolster the field? The thing that I keep hearing from our scientists and from the Jim Allisons of the world is that we are on this sort of precipice of potentially losing an entire generation of scientists who are training today as postdocs, but unfortunately aren't seeing a bright future in front of them because of the funding environment. It means that there are less job opportunities, there are less institutions that are hiring, and it also means that there's less funding opportunities for them in their projects. And so this is an important moment for the field to really rally around this generation of researchers. And so for us at CRI, I'm always trying to make sure folks understand we have funding mechanisms, we have grants these talented trainees and early career faculty. So we have postdoctoral fellowships that we want folks to be applying for. We have these early career transition award that we just announced called the Ignite Award, and it's actually specifically to fund the transition between postdoctoral fellowship and junior faculty. And we also have our STAR Award that funds mid-career faculty, sort of when you're on that tenure track, chasing for that tenure. And so I always want to encourage folks to explore our funding mechanisms, especially in this moment where we're seeing a contraction, to make sure that we can do the most we can to support the scientists, especially in this moment.
Thank you very much, Alicia. And the last question, which I usually ask to every guest I'm fortunate to have, who I should interview next.
Okay, this is like I have to there's a bunch of folks that I could think of. I imagine you've actually interviewed a bunch of them already.
Maybe.
I assume you've already chatted with Jim Allison, but
I haven't the chance.
Oh, really? Well, Jim obviously is an incredible person to talk with. But also
I would need your introduction, but
I think Dr. Liz Jaffe at Johns Hopkins, she's done an incredible amount of work in the cancer vaccine field and is truly a pioneer. So she's somebody that I think you should definitely talk to.
Wonderful. I will. Thank you so much, Alicia. It was really a great pleasure.
Fantastic.
And thanks a lot.
Don't forget to like, comment, share, and subscribe to OncoDaily on YouTube. Hit the bell icon to stay updated.